Hey guys, we are back with the experimental technique past papers, and this is question number 24, question number 44 here. Yes, it is 44. Okay, great. So 25 centimeter cube of an alkali are added to 20 centimeter cube of an acid. The temperature change is measured, which apparatus is not needed in this experiment. Okay. So 25 centimeter cube of alkali, okay, done. We can measure it with the measuring cylinder. 20 centimeter cube of an acid, we can measure it with the measuring cylinder as well. And the temperature can be measured with the thermometer. All right. And here, what is not needed? Actually, here we are not needed with the balance. Okay. Why 100 centimeter cube of a beaker is required? So that we may keep one, for example, one liquid in one apparatus and the other liquid in the other apparatus. That's another thing. But balance is definitely not needed. Why it is so? Because we are not measuring any change in the mass of a solid. Okay. So as far as solid is not concerned, we are not going to discuss about the balance. And here in this case, no gas is forming. Examiner is not telling about any gas formation. By the way, before moving ahead, I would like to inform you that whenever an alkali and an acid are reacting with each other, they are making salt and water, and this reaction is called neutralization reaction. Okay, as no gas is forming in this reaction, as no solid is concerned over here, that's why we are not requiring any balance over here. The painkiller paracetamol is synthesized from 4-aminophenol. All right. Chromatography was carried out on an impure sample of paracetamol. The results are shown, not drawn to scale. All right. Now they are asking the sample of paracetamol was contaminated with 4-aminophenol only. All right. Now, what is the RF value of 4-aminophenol? All right, so it means that we are going to calculate the RF values. For example, here we are going to calculate the RF value for P. Here we are going to calculate the RF value for S this point and S this point. And then we can say this thing that this is the distance traveled by the solvent. So impure sample of paracetamol is S and pure sample of paracetamol is P. So we are going to calculate the RF values of all, and then we can say that what is the result. But remember this thing, that how to calculate the RF value for paracetamol. It is the distance traveled by P divided by distance traveled by solvent. So again and again we are practicing the same type of the questions to tell you that how to calculate the RF value. I am telling you again and again, it is the smaller distance divided by the bigger distance. Distance traveled by the spot divided by distance traveled by the solvent. Solvent distance is called as solvent front. Okay. Here we are on the next question. The results obtained from a chromatogram are shown. Okay, which row gives the RF values of the substance X and Y? All right. So this is the substance X and this is the substance Y. Substance X should have a greater RF value because substance X has traveled higher distance. Okay, so higher it is, can be this, it can be this as well, but the difference should not be that much bigger. Let's check the RF values. Okay, so how to calculate the RF values of X? It is 3 divided by 5. And what about the RF value of Y? It is 2.5 divided by 5. Okay, let's calculate. So it is a very simple calculation. That is the 3 which is given, and 3 is divided by 5 is giving you 0.6, whereas 2.5 divided by 5 is definitely giving you 0.5. So this is how we are going to calculate the difference. Okay, and calculate the distances, measure the distances and calculate the RF values. So this is the answer B here. Okay, now, during an experiment, our measurement is recorded in centimeter cube. Okay, this is centimeter cube. Which apparatus is used? Balance? No, it is in gram. Stop clock? No, it is in seconds. Thermometer? No, it is in centimeter. It is in degree Celsius. Okay, or degree Fahrenheit or Kelvin as well. Now, the measuring cylinder is the only apparatus which will be used for the measurement of the liquid. Centimeter cube and decimeter cube along with meter cube are the different measurements for the liquids. Okay. So a student carried out paper chromatography on a mixture of amino acids. All right. As the students spray the dried chromatogram with a locating agent. We should know this thing that locating agent is sprayed for that chromatogram on which the spots are colorless. This locating agent is not sprayed on every chromatogram. Okay, be aware of the fact. This locating agent will be sprayed on a chromatogram which has no color. Okay, be aware of this fact and keep this in your mind. So, what is the function of locating agent? To dissolve the amino acids? No. To form colored spots with amino acids? Yes. To preserve the amino acids? No. To stop the amino acids reacting? No. It is to make them visible. Okay. To make them colored. Okay. A student used chromatography to analyze a green food coloring. The chromatogram obtained is shown. This is a blue spot, this is a yellow spot, this green is shifted into two spots. Okay. The table listed some yellow food dyes and their RF values. Which yellow food dye does the green food coloring contain? Okay. So we are going to measure the distance of this yellow dye, and we are going to measure the distance of this solvent front, and this distance x will be divided by this distance y. So this is like this. Okay, and then you can say this thing that what is the answer here. You will see this, that what is the RF value. It is quinoline yellow or sunset yellow or tartrazine or yellow 2G, any yellow which is present. You are going to measure the distance and then calculate the RF value, and then you can see say very clearly A, B, C, D, whichsoever is the option. Okay, then a student put 25 centimeter cube of dilute hydrochloric acid into a conical flask. All right. The student added 2.5 grams of sodium carbonate, formula Na2CO3, and measured the change in the temperature of the mixture. Which apparatus does the student need to use to obtain the most accurate results? Okay, so what student is doing? 2.5 grams of sodium carbonate. It means the student needs a balance. Okay, so it can be A, B, C. So it means that we are omitting D because we are requiring something in grams. And when something in grams is there, it means we are requiring a balance. Okay. Then 25 centimeter cube. Whenever there is a 25 centimeter cube, it means that you should know that pipette is required. So it is either B or C. Okay. Then it is the temperature. That is the thermometer. So this is C option. Okay. So we have to look into the things which examiner is measuring in a chemical reaction. If temperature, then thermometer. If 25 centimeter cube very accurately, then it is pipette. If gram, then it is a balance. So we are looking into the questions. This practice of the question will increase your analyzing ability, will increase your evaluation ability, your ability to think about the question in a right way. Hence, in this way, you can find out which options I can cut out and which option can be the right option. Okay. There is again a question related to chromatography. The diagram shows a chromatogram of four substances. Which substance has an RF value of approximately 0.32? All right. So you have to measure the distance of A, the distance of C, the distance of B, the distance of D, and divide all these distances. Rather lucky we have the distances, so it will be for A, it will be 6 divided by 19, and for B, it will be 14 divided by 19, and for C, it is 4 divided by 19, whereas for D, it is 12 divided by 19. Okay. So in all cases, we have to look into the fact which is giving you 0.32. All right. A compound X has a melting point of 71 degrees Celsius and a boiling point of 375 degrees Celsius. Which statement about X is correct? Okay. It is liquid at 52 degrees Celsius and gas at 175 degrees Celsius. It is liquid at 69 degrees Celsius and gas at 380. All right, remember this thing. A substance is liquid between its melting point and its boiling point. Just consider the example of water. Water's melting point is 0 degrees Celsius, whereas water's boiling point is 100 degrees Celsius. So what will be the state of water at 50 degrees Celsius? It will be liquid. What will be the state of water at 20 degrees Celsius? It will be liquid. What will be the state of water at 75 degrees Celsius? It will be liquid. So it will start evaporating more and more quickly when temperature of water will be increased. That's another thing, but it will be remain in the liquid state. What will be the state of water below 0 degree centigrade? It will be the solid. And what will be the state of water above 100 degrees Celsius? It will be a gas. Okay. So they are asking that it is liquid. They are asking about liquid. So it is liquid at 52 degrees Celsius. No. Why? Because 52 is lesser than 71. It is liquid at 69. No. 69 is also lesser than 71. It is liquid at 75. Yes, it is a possibility. It is liquid at 80. Yes, it is a possibility again, because 75 and 80 both are above 71, but the temperature should be lesser than 75 as well. 375 as well. So 71 is the lowest limit and 375 is the highest limit. So what is the answer here? It is C. Why? Because 75 degrees Celsius and 350 degrees Celsius both are between 71 degrees Celsius and 375 degrees Celsius. So keep this information in your mind, that below melting point the substance is solid, above boiling point the substance is gas, and between melting point and boiling point the substance is liquid. All right. So this is very important to keep analyzing the questions like this. Okay. So question number 35 onward, this will be part of the next video, inshallah. Thank you very much. Take care of yourself.